Welcome. Since matrices are so difficult, I thought we would do kind of a review lesson and let you continue to practice some of these operations and working with matrices. I'm going to assign two lessons though for my Excel. I'm going to assign L2 and L7 from the pre-calculus sections. And again, let's just talk a little bit about what they are. Lesson 2 or L2 should go pretty quickly. It's about matrix operation rules. And you're really not going to be doing any arithmetic. You're just going to be telling me if something can be done or not. And if it can be done, what will the size of the solution be? So let me clarify. First of all, you're going to be given matrices. And matrices are usually given a name or labeled with a capital letter. So this could be matrix A, which is a 2 by 3 matrix. And again, that's one thing we want to remember is that we talk about the size of the matrix by the number of rows by the number of columns. So this had two rows, that's this 2, and it has 3 columns. 1, 2, 3 columns. So it's always designated by the rows first and the columns second. The next thing I want to emphasize is that when we talk about scalars or a multiple scalar, those are always given a lowercase letter. So A is just the number 7. It's not a matrix, it's just a scalar. It's going to make things larger or smaller. Okay. Now, the next thing I want to emphasize is that when you multiply by a scalar, because we're going to be talking about operations, when you multiply by a scalar, it does not change the size of the matrix. So in other words, if matrix A up here was a 2 by 3 matrix, and we multiplied it by A, or 7, lowercase a, 7, the outcome will still be a 2 by 3 matrix. All that's going to do is raise all of these by a factor of 7. So this would become a 14, a 21, a negative 42, a 49, negative 84, and 28. But it'd still be a 2 by 3 matrix. So multiplying by a scalar does not change the size of a matrix. The next thing I want to talk about is when we add and subtract matrices, which we've done in a previous lesson. But just remember, when we add and subtract, those matrices must be the same size. So in other words, let's say I have these 5 matrices, and I don't know what the terms are, the elements in them are, but I know A is a 2 by 3 matrix, B is a 5 by 5 matrix, C is a 3 by 2 matrix, D is a 3 by 5 matrix, and E is a 2 by 3 matrix. Now remember, the first is the number of rows, the second number is the number of columns, but when we go to add, there would be only 2 of these matrices that could actually be added together. That would be matrix A and matrix E, because they're the same number of rows and the same number of columns. All the other ones would be different. I don't care if one number is the same, both have to be the same. So since 5 doesn't match 3, or the number of rows doesn't match the number of rows, we could not add B or D. All others would be undefined because they are not the same size. Next thing we want to talk about again and review is multiplying matrices. When you multiply matrices, the number of columns, and I made sure I got this right this time, when you multiply matrices, the number of columns, this second number, the number of columns in the first matrix, that should be in the first matrix, must be the same as the number of rows, that's the first number in the second one, of the second matrix. So these two numbers must be the same. The number of rows in the first column and the number of columns in the second matrix can be anything. And that's what your solution will end up being. So if you multiply, let's say you multiply that's not writing for some reason, a 4 by 7 by a, now this next one, in order to be able to multiply, this has to be 7 rows by, I don't care what this number is, 2. As long as these two middle ones are the same, your outcome will be this is the number of rows it will have, a 4 by, and this will be the number of rows it has, 2 matrix. So the outcome is always the number of rows in the first and the number of columns in the second, and you can only multiply if the number of columns in the first and the number of rows in the second match. Those two match. So again, here we have some matrices defined. We have an A is a 2 by 3, a B is a 5 by 4, a C is a 3 by 2, a D is a 3 by 5, and an E is a 2 by 3. By the way, I want to also emphasize order matters when it comes to multiplication. If I wanted to multiply A times B, that would be undefined. So would B times A. Because if I was to do A times B, A is the first, does 3 match 5? No, it doesn't. So we could not multiply A times B. But if I wanted to multiply, if I try to multiply in the reverse order, B, so I'm going to do B is the first one. So this would be my number of columns. Does that match my number of rows in my second matrix, my matrix A? No, they don't. So they would be undefined. But now let's jump down here. Sometimes we can multiply in both directions. Now, by the way, the outcome will be different. If I multiply A times C over here, so let's erase this one here. If I multiply A times C, first thing I'm going to do is I'm going to want to make sure that my number of columns in the first one matches the number of rows in the second one, and it does. 3 matches 3, right? That's when I'm multiplying A times C, right? And I want to then say my outcome will be the number of rows in my first one by the number of columns in my second one. That's where I get this 2 by 2. But if I reverse the order, let's say I reverse the order, then what's going to happen is I'm going to first have to make sure that the number of, now C, see I'm down here on this one, looking at this one, C in the first matrix, I have 2 columns. In A, my second matrix, I have 2 rows. That allows me to multiply them together. And then my outcome will be the number of rows in the first column, or first matrix, by the number of columns in the second matrix. That's why I get a 3 by 3. So you'll notice that the order absolutely mattered on what our outcome would be. A 3 by 3 matrix is completely different than a 2 by 2 matrix. So sometimes order neither can be multiplied, sometimes both can be multiplied, and you get a different solution. Or sometimes in one order, like if I try to multiply B times D, I couldn't do that because 4 does not match 3. But if I reversed the order and did D times B, I could, because 5 matches 5. So remember, order matters when we multiply, and then to be able to multiply, the number of columns in the second one must be the same as the number of rows in the number of columns in the first one must be the same as the number of rows in the second one. Now let's just do a little quick example of what you'll be doing in L7. L7, you'll be simplifying matrix expressions. So they'll give you like A is this 2 by 2 matrix, B is a 2 by 1 matrix, C is a 2 by 2 matrix. They'll give you a couple scalars, 3 and -2, and they'll give you some expression to evaluate. Now, by all means, you can take the time to evaluate it. What I've done is I put my 3, my M is 3, matrix A is 1, 2, -3, 4, matrix B is 5, 7, add, N over here is -2, C is 3, 0, -1, -2. Now, again, order matters, but order this multiplication with the 3 here. I can multiply the 3 together first, or I can multiply these 2 together first. So if I multiply these 2 matrices together first, so I'm not doing the 3, I'm leaving the 3 out in front, I'm going to do this row times this column, that's right here, 1 times 5, there's my 1 times 5, 2 times 7, there's my 2 times 7, and then I add them together, and I get 19. So row 1 times column 1 gave me 19. There's no second column in the second matrix, so I go to this next row. And I'm going to do row 2, which is negative 3, 4. And that should be a negative 3, not a negative. Oh, no, sorry, I'm over here. That's correct. Sorry. I'm looking at this one now. I'm doing this one is this row the first row. I'll get it right here. Like I said, matrices takes time. The second row times this one column. That's this. Negative 3 times 5, negative 3 times 5. That's the first element times the first element. 4 times 7, that's the second element times the second element. We add those together and we get this term right here, this 13. Right? And so I can multiply those two matrices, and then when I multiply the 3 in, I get this 57 and 39. Here, I basically combine the positive and the negative like this, and then I distribute it in. Or what I could do is I could distribute the 3 in first. 3 times 1 is 3, 3 times 2 is 6, 3 times negative 3 is negative 9, 3 times 4 is 12. So this going down, I multiplied the 3 in first. Going over this way, I actually multiplied the two matrices together first. So it doesn't matter there. And then down here, I've taken this one and I've multiplied the first row by this column. That's right here. Right? Got my 3 and my negative, or 3 and my 6, 3 and my 6. That's that first row. My column is 5 and 7. I add times the 3 and 5, got 15. 6 times 7 is 42. Added them together, got 57. That's this term here. Over here, I did my second row times that first column. So the second row times this first column. My negative 9 and 12, negative 9 and 12, 5 and 7. 5 and 7, I multiplied the negative 9 and the 5, got negative 45. 12 times 7 is 84. Add them, we get 39. And so then we get here. But now we get down to here, and we need to add these two together. But guess what? We can't add them. We did all that work for nothing, because when we get to this point, we can't add them because these two matrices are not the same size. So this expression is actually undefined. So what I would recommend doing, rather than doing the work at the beginning, walk through the steps with just the size of the matrix. First of all, remember that when we multiply by scalars, the size of matrices don't change. So I'm going to ignore these scalars and just do what's A times B. Well, A was a 2 by 2 matrix. B was a 2 by 1 matrix. 2 by 1 matrix. And then I'm going to add that to this scalar. And again, I don't worry about scalars when it comes to size. So C is a 2 by 2 matrix. So I'm going to add that to a 2 by 2 matrix. And now order of operations says I do this multiplication first. So I make sure I look here and say, okay, the number of columns does equal the number of rows. So what's my outcome though? My outcome is going to be this number of rows by this number of columns. So this would be these first two multiplied together, maybe I'll do a different color. These two multiplied together would just be a 2 by 1 matrix. And now I'm going to add that to a 2 by 2 matrix. And I can stop right there and tell myself, hey, wait a minute. I can't add those together. They're not the same size. This expression is undefined. So when you're doing L7 in IXL in the pre-calculus section, try to do it through addition of the multiplication addition of the sizes first, just saying, okay, what are the sizes of these outcomes, and finding out if it's undefined. Once you find it's undefined, you're done. You don't need to do all this extra work. If you do get a final outcome or a solution that does work, then you'd have to go back and do all the work. If you have any questions, please contact me via email or log on to my online office hours at 1 o'clock. and I will help you then.